Hi, today we're going to talk about the 6.3 bisectors of triangles. So what you will learn in this section is you will learn how to use and find the circumcenter of a triangle. And also you will learn how to use and find the incenter of a triangle. So let's start here with this vocabulary. So this one is the circumcenter theorem. So the circumcenter of a triangle is equidistant from the vertices of a triangle. It means that this red are all equal. So this is what you call the circumcenter theorem. When three or more lines, rays, or segments intersect in the same point, this is called the point of concurrency. And also the point in a triangle, this one, the point of a triangle where the three perpendicular bisectors are concurrent. This is what you call the circumcenter. Okay, so these are the definitions of circumcenter, and I also put the illustration here. You can see that this side, they're both equal, and also this side, you can see this side and this side are equal, and also this side or this side are all equal. And you may see also in the violet, the purple one, the three lines indicates the circumcenter at the center of the triangle. All right, so let's have here an example one. So for our example one, three snack cart sell hot pretzels from point A, B, and E. What is the location of the pretzel distributor if it is equidistant from the three carts? Sketch a triangle and show the location. So in this one, we're talking about if we make a line on this one, which is equidistant, it will have a circumcenter here, or the point. Okay, but also we have three types of the circumcenter, which is the first one is the acute triangle, where you can see that the P is inside the triangle. Okay, and it has a circle, and the triangle is inside of the circle. Okay, and also can have the right triangle, and you may see that the P is on triangle. Take note of that. This one is inside the triangle. This one is on triangle. And for the obtuse triangle, it says here P is outside the triangle. So you can see that P is outside the triangle. So that's the three kinds of the circumcenter. Okay. Now, let's have an example here in circumcenter of a triangle. So we have three coordinates here. So let's try to graph it first. So -2 and 5, that would be, let's say -2 and 5, 1, 2, 1, 2, 3, 4, 5. Somewhere here. Okay, let's say this is, the name of this point is R, and -6 and 5, so 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. And this is point S. And also the other one is -2 and -1, so 1, 2, and then 1. And this point called T. So we can make a line. So let's make a line here. Okay. And then this one. Let's connect them. Okay. Okay. So now we have here a triangle, and if we look at the triangle, let's use this graph to find the midpoint. So the midpoint from R to T is here. So this is the midpoint, which is the midpoint is -2 and +2. Let's put it as midpoint. And the midpoint from S to R would be on this part. That would be -4 and 5. 1, 2, 3, 4. Okay, we're correct on that one. And we can make a line here so that we can find the midpoint. Okay. And then the other one. Okay, so the midpoint, this line is on this part, and this one is -4 and 2. -4 and 2. Okay, so this will be the circumcenter of the triangle with the given vertices. All right, so we can also follow the steps in finding the midpoint because sometimes it's difficult to just visualize it. Use the graph. So let me write the steps in finding it. The first step is you will use the midpoint. So find the midpoint first, which is the formula of finding the midpoint, which is x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. So in this formula, you can easily find the midpoint, the exact midpoint of the given vertices. The second step is to find the slope. So the formula for finding the slope is m is equal to y2 minus y1 over x2 minus x1. And then the third step, actually this step is finding also the equation of the intersection or the mid circumcenter of a triangle or the line. Okay, so the third step is find the perpendicular slope, just like what we did in finding the equation of the perpendicular line. So opposite or the reciprocal. The formula on that one is actually m is equal to 1 over negative m. Let me put the perpendicular sign. Okay. Number 4, third step is find and graph using the y is equal to mx plus b form. Using the y is equal to mx plus b form, using the midpoint, coordinates and the perpendicular slope. Let me just put it as m. Okay. And also, the last step is just find the intersection of all three. Okay, so let's follow these steps in doing example 3. So let's graph it first. So we have 3 and 5. So this is the start. So 1, 2, 3, 1, 2, 3, 4, 5. So this point. This is D. And then for E is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. This point, this is E. And also the F is 11 and 5. So 1, 2, 5, 6, 7, 8, 9, 10, 11 on this part. So let me put a line on them. Okay. Okay, the other one, this part. Okay. Okay, now we have the triangle. Now, we're going to find the circumcenter of the triangle. So first, let's find the midpoint. The midpoint of, say, the DF. This is the DF, line DF. We can easily find the midpoint on this one. So this one is the midpoint, which is, this one is, the coordinates is 7 and 5. You can say that this is 7 and 5. So that's the midpoint of DF. Now let's find the midpoint of DE. Line DE. Okay, so on this one, to be accurate, okay, can use the coordinates of D and E. So I'm gonna use it just to show to you the exact point or the exact midpoint. 3 plus 7 over 2, and then the second one is 5 plus 9 over 2. 7 plus 3 is 10 divided by 2 would give me 5. And then the second one, 9 plus 5 is 14 divided by 2 would give me 7. Okay, so that's the midpoint of DE. So 5 and 7. This part. Okay. And then for finding the equation of that line, because we're gonna make a line here, so we need to find the equation of this line. Okay, so to find the equation of the line, we're gonna use this as our midpoint, and also the following coordinates of D and E to find the slope first. So let's use the slope of M is equal to 9 minus 5 over 7 minus 3 is equal to 4 over 4 is equal to 1. So our slope here is 1, and then using the second step, this is the first step, this is the second step, third step is finding the inverse. The inverse of this one would be -1. And then let's plug in our equation. So using the y is equal to mx plus b, can easily find using the midpoint, that would be 7 is equal to our slope here is -1, and our x is 5 plus b, and then 7 is equal to -5 plus b, and then moving the 5 on the other side would give me b is equal to 12, and then using this b is equal to 12 would give us the equation. So can now say that the equation of this line in the purple one would be y is equal to, since our slope is -1, so it would be -x, and then our b here would be 12. So this will be the equation of that line. Now we need to find the other. Let me just edit this one. Okay. Okay. Let's find the equation of this line, or the midpoint first. Let's find the midpoint of EF. So to find the midpoint of EF, that would be, okay, let me just put it in this way. So 3, the midpoint of D or EF, my bad, is equal to, let me use the coordinates. So 7 plus 11 over 2 and 9 plus 5 over 2. The coordinates that I'm using here is this E and F. So just giving you an idea on what am I using. So 7 plus 11, that would be 18 divided by 2 would give me 9. And then 9 plus 5 would be 14 divided by 2 would give me 7. Okay, so this is the midpoint. And then the second step we're going to do is find the slope. So M is equal to, using again the given points of, or the vertices of E and F, which is M is equal to 5 Minus 9 over 11 minus 7 is equal to negative 4 over 4, would give you negative 1. And then the slope would be, perpendicular slope will be, the inverse of negative 1 would be positive 1, because our formula is negative 1 over m. And following the same process that we did, so using the perpendicular slope, okay, the fourth step is the y is equal to mx plus b. It's the first step, second, third step, and then the fourth step. So using this one, let's find the b. So our y here, using these coordinates, would be 7 is equal to 1 multiplied by 9 plus b, and then would give me 7 is equal to 9 plus b, and then moving the 9 on the other side would give me b is equal to negative 2. And then from this, we can now find the equation of this one by writing again this one as y is equal to, our m is 1, so would be just x, and then adding this as our b would give me the equation of the other line. So let's put a line here. Okay, and also the midpoint would be on this one. So actually, we're just finding the circumcenter of the triangle, but I shown you how to find the equation of the line that we are using in our graph. Okay, now let's move on to this example 3 using the in-center. So for an in-center theorem, so this is in-center theorem. So the in-center of a triangle is equidistant from the sides of the triangle. It means we have the circle inside of the triangle. In our first example, the circle is outside, but in this in-center, the circle is inside of the triangles. That's why this side, and this side are all equidistant, and they are all equal. Okay, so let's have an example here. So on this one, it says that the QM, let's put it, QM is equal to 3x plus 8. And the QN, this part, is equal to 7x plus 2. Now we need to find the QP. So what would be the length of that QP? So based on the definition, let's put it this way. So line PQ is equal to line NQ and also equal to line QM. Since we're finding the PQ and we were given the two sides, so we can use the two sides or the two lengths, which is for line QM, the line QM is 3x plus 8. Line NQ is equal to 7x plus 2. So using this, we can find the length of each. So minus 3x and then minus 2 would give me 4x is equal to 8 minus 2 would give me 6. And then dividing both sides by 4 would give me 4. Oh, x is equal to 6 over 4 in simplified form or in decimal would give me 1.5. So I'm going to use this x to find. My bad. What's happening? Okay, so this part, let me just... Okay. So using the x is equal to 1.5, we can choose which side you're going to use. Okay? So I'm going to use the line MQ since they are all equal. So line MQ is equal to 3x plus 8. I'm just going to change the x into 1.5 plus 8. And then this one would give me, the line MQ would be equal to 12.5. So therefore, all sides, or the QP, is equal to 12.5. Okay, so that's the in-center theorem. Now, let's have a last example here, the real-life example. Okay, so on this one, the city wants to place a lamp post on the boulevard shown so that the lamppost is the same distance from all three streets. So let's this one, same distance from all the three streets. Should the location of the lamppost be at the circumcenter or in center of the triangle boulevard? Explain. So this one, because it's saying same distance from all the streets. So as what you have seen in our figure here, we have the streets here and it says that same distance from all the streets. So on this one, my answer here would be the in center. Why? Because the in center should be used since it is equidistant from all sides. So this is my reasoning. So that would be the end of our 6.3. I hope you understand, and if you have any questions, feel free to ask me.